In this lesson, you will learn to state and apply the converse of the Pythagorean theorem. In the last lesson, we learned the Pythagorean theorem to be c squared equals a squared plus b squared. And that is only true if you have a right triangle. So Pythagorean theorem says if you have a right triangle, then c squared equals a squared plus b squared. The converse of this is when you switch the if and the then statement. So what we have instead would be now if c squared equals a squared plus b squared, then you have a right triangle. So we're going to use this converse today in this lesson, where remember, c is your hypotenuse, or we can think of it as being the longest side. So using this information, we would then have two different theorems based off this, which in this lesson we're not going to take the time to prove those theorems, but we have three different statements that we have. So the converse would be true. So we have if c squared equals a squared plus b squared, then the triangle is a right triangle. Okay, so if c squared equals a squared plus b squared, the measure of angle c would be 90, making the triangle a right triangle. Now the two other statements would be if c squared is less than a squared plus b squared, where remember c is going to be the longest side, then the measure of angle c is less than 90 and the triangle would be acute. Okay, so if c squared is less than, then measure of angle c is less than 90, making the triangle acute. And then if c squared is greater than a squared plus b squared, then angle c is greater than 90 degrees, and therefore the triangle is going to be obtuse. So that is basically the entire lesson, but we're going to now give a few example problems where you're told to answer, is a triangle a right triangle, acute, or obtuse, given only the side lengths. So here's a triangle that have sides of 6, 8, and 10. And the question is the triangle acute, right, or obtuse? So remember that in the Pythagorean theorem, c will always be the biggest side. So I will let c equal the biggest side length, which would be 10. Then a and b can be either 6 or 8. It doesn't matter if a is 6 or a is 8, and then b is 6 or b is 8, as long as c is the longest length. So then, if I squared everything, we'd have c squared equals 100, a squared would be 36, b squared would be 64. So the question is, how does c squared relate to a squared plus b squared? So c squared is 100, a squared plus b squared would give me 36 plus 64, which would also equal 100. So c squared would equal a squared plus b squared. So therefore, this triangle would be a right triangle. Example 2, we have the side lengths of 4, 8, and 6. So remember, c, your hypotenuse, will be the longest side. So the 8 will let be c, and then 4 and 6 will let be a and b. So then we'll square everything. So c squared would be 64, a squared is 16, b squared would be 36. And the question is, how does c squared relate to a squared plus b squared? So c squared is 64, a squared plus b squared would be 16 plus 36. Notice 64 would be bigger than 16 plus 36 because that would give me 52. So c squared is bigger than a squared plus b squared. Therefore, that angle c, would be bigger than 90 degrees, and we would have an obtuse triangle. Here's another example where we have side lengths of 4, 7, and 6. C will be the longest side length, which is going to be 7, and then a and b would be 4 and the 6. So then we square everything. We get c squared is 49, a squared is 16, b squared would be 36. So the question is, how does c squared relate to a squared plus b squared? So if I add 16 plus 36, that would give me 52. So notice that is bigger than c squared. So c squared is less than a squared plus b squared. Therefore, angle C is going to be less than 90, making this an acute triangle. Here's one last example. We are given 3 sides, but in this case, we have a square root in there. So C will be the longest side length, which is going to be 8. And then A and B would be 4 and 4 square root of 3. So if I square everything, 8 squared is 64. 4 squared would be 16. But then when I square 4 times the square root of 3, make sure you know how to square that. Where when you square that, you are squaring the 4. So we have 4 squared. And then you square the square root of 3 as well. The exponent would carry to both parts of the parentheses. So 4 squared is 16. The square root of 3 squared. The square and the square root will cancel each other. I'm left with a 3. So I have 16 times 3, which would give me 48 for b squared. So if I were to compare c squared with a squared plus b squared, I would have 64 on the left side, and then 16 plus 48 would give me also 64. And this should not be greater than, but an equal sign, because that's going to be equal. And then this would also be equal. 64 is equal to 64. So therefore, we have a right triangle, because c squared is equal to a squared plus b squared. Now you might be wondering, well, how do I know with a radical if this is bigger than the other numbers? So maybe we knew, in this case, that 8 was bigger, but what if c was like 5 or 6 or something? And it was kind of close to 4 square root of 3. Well, what I could still do is just simply square everything and look at this step, and if the number is bigger here, then it was bigger before I squared it as well. So we see 64 is bigger than the other 2 numbers. Well, 64, the square root of that would have been bigger than the other square roots as well. So looking at this step, we can conclude which one is A, B, and C if you're not sure. And that concludes our lesson for today. We will see you next time.